In this video series, I work through a math problem or problems each video. Positive integers can be classified into three types of numbers. First, prime numbers are numbers that have only two factors, 1 and the number itself. For example, the only factors of 5 are 1 and 5. Second, composite numbers have at least one number besides 1 and the number itself as a factor. For example, the factors of 6 are 1, 2, 3, and 6. And finally, the number 1. As a consequence of the unique factorization theorem, we can rewrite a positive integer bigger than 1 as a multiple of prime numbers only. Most numbers we encounter in problems can be factored into prime numbers only if we remember a few facts. First, all composite numbers less than 100 are either divisible by 2, 3, or 5 except 91, which is divisible by 7 and 13. Second, all even numbers are divisible by 2. Third, digital roots of all numbers divisible by 3 are also divisible by 3. Fourth, all numbers divisible by 5 have the ones digit equal to either 0 or 5. And finally, when checking numbers to see if they are prime, by dividing the number by primes, we need to check primes only up to the square root of the given number, rounded down. Let's take a look at the examples. We need to factor the following numbers into prime numbers. First, we have 420. Since this number has the ones digit equal to 0, we know that 420 is divisible by 10. So let's divide this number by 10, and we get 42 and 10. Next, we see that 42 is equal to 6 times 7, so we can write 42 as 6 times 7. And 10 can be written as 2 times 5, so let's do that. And finally, 6 is equal to 2 times 3, so I'll go ahead and rewrite 6 as 2 times 3. And now 420 we know has a factor of 2, 3, 7, 2, and 5. We usually write the factors in increasing order, so let's start with 2. So we have 2, but there's 2 copies of 2, so we usually write that as 2 squared. Then next we have 3, then 5, and then finally 7. Next, we need to factor the number 1155. If we look at the ones digit, we see that it's equal to 5, so we can divide this number by 5. So this number is equal to 5 multiplied by, let's see, we get 2. 11 minus 10 is 1. We bring the 5 down. 15 divided by 5 is 3. And finally, 5 divided by 5 is 1. Next, let's take a look at what we discussed earlier, the digital root of 231. We're going to start with the number 231. We take each of the digits separately and add them together like this. 2 plus 3 plus 1 is equal to 6, and 6 is the digital root of the number 231. So what we can show is that if this number, the digital root, is divisible by 3, then this number here, 231, is also divisible by 3. And since 6 is divisible by 3, 231 is also divisible by 3. So let's go ahead and divide 231 by 3. We get 5 multiplied by 3. 3 times 7 is 21. 23 minus 21 is 2. 21 divided by 3 is 7. And 77 is equal to 7 times 11. So we can write this as 5 multiplied by 3 multiplied by 7 multiplied by 11. And if we write this in increasing order, we get 3 times 5 times 7 times 11.